Our next topic is correlation. See the first definition of correlation. Correlation is a statistical tool used to measure the relationship between two sets of variables and express each in a precise manner. You observe here, correlation is a statistical tool which is used to measure. What we are going to measure? The relationship between two sets of variables and express each in precise manner. Okay, ma'am. Two sets of variables. Minimum we need two sets because relationship, we mentioned relationship here. So to measure the relationship, minimum we need two sets of variables. Usually we take it as X set and Y set. Okay, minimum two sets we need here. So correlation is the measure relationship between two sets of variables. Okay. Another definition is an analysis of the covariance of two or more variables is usually called correlation. Analysis of covariance of two or more variables. Okay, two or more variables. Minimal we use the two sets of variables to talk about the correlation. Types of correlation. SEMA. These types basis on the three main concepts that are on basis of direction, on basis of number of variables, on basis of the ratio of change of direction. On basis of direction means these have two types, negative correlation, positive correlation. On basis of number base cheskoni, simple correlation. Okay ma? Next multiple correlation and partial correlation. Then on basis of ratio of change, there are two types, linear and non-linear correlations. Now we see the definitions of all these types correlation. First we see negative, positive, first part. Okay, negative correlation. This is also called as inverse correlation. Two variables are said to be correlated. Here negative is there. Two variables are said to be negatively, add the word negatively correlated when both variables vary in opposite direction. For example, price and demand. You see, suppose apple's cost is increasing, then demand decreasing, because if cost is very high, people buy little quantity of apples. Suppose the price is decreasing, then demand increasing, because cost is very less, price is very less, people buy lot of apples. Okay, price and demand, price increase, demand decrease in opposite direction it means. Okay, so for negative correlation, price and demand examples. Positive correlation, if two variables, same definition in place of opposite you let same direction. Two variables are said to be positively correlated when both variables vary in the same direction. Example, demand and supply. For example, nowadays the masks are very demand. Masks have very demand because of COVID. Okay, if demand is increasing, then supply is also increasing. Like big companies, fabric companies also manufactured masks nowadays. So demand ఉంది కాబట్టి మాస్క్ కి సప్లై కూడా చాలా ఎక్కువగా ఉంది. సో డిమాండ్ ఇంక్రీస్, సప్లై ఈజ్ ఆల్సో ఇంక్రీస్ ఫర్ ఎనీ ఐటమ్స్. ఓకే, పాజిటివ్ అండ్ నెగటివ్ కరోలేషన్స్ ఆన్ బేసిస్ ఆఫ్ డైరెక్షన్స్. ద సెకండ్ వన్ ఈజ్ ఆన్ ద బేసిస్ ఆఫ్ number of variables. Mainly there are three types. Simple correlation means it is a measure used to determine relationship between two variables only. Minimum we need two variables for correlation coefficient. So correlation means relation between variables. Minimum we need two. If there are minimum number, that means two variables, only two variables are there, then the correlation is simple correlation. Suppose not only here you is price and demand and supply. Okay, only two variables. We are talking about two variables, price and demand, or demand and supply, any two, that's it. Multiple correlation, it is a measure used to determine the relationship between multiple variables. And more than two variables. Okay, more than two variables. Rainfall, temperature. It means rainfall in number of towns. For example, today the rainfall or temperature. Today's temperature in Tirupati, in Hyderabad, in Vijayawada, in Nellore, in Vizag, like that. That is so many variables. Towns, let towns as variables here. There are so many variables, multiple variables. So this correlation is called multiple correlation. Partial correlation. Suppose the study of variables excluding some other variable is called partial correlation. Suppose we take three variables like price, demand, supply. We are talking about only price and demand and eliminate the supply, then it is called partial correlation. It is called partial correlation. The last one is on the basis of ratio of change of direction. Ratio of change of direction. Here mainly we have two correlations, two types, linear correlation and non-linear correlation. First we see linear correlation. If the study of change between two variables is uniform, then there can be linear correlation between them. If the study of change between two variables is uniform, then there is linear correlation is there. Here in place of uniform you put not uniform, then we get non-linear correlation. In this linear correlation, suppose you plot that variables in a graph paper, you get a straight line. But in non-linear correlation, suppose you plot the variables on graph paper, you don't get a straight line, you get a curve. So the second one is also called as curvilinear, non-linear. In place of non-linear, you use the word curvilinear correlation. Okay, now we have observed the types of correlations. Then the topic is coefficient of correlation. How can we find the coefficient of correlation? Here Corrollation. This coefficient of correlation is called as Corrollation coefficient of correlation. In examination also the questions are given like find the Corrollation coefficient of correlation. Okay, or simply asks find the coefficient of correlation or Corrollation coefficient of correlation. There are so many formulas for finding the coefficient of correlation. First formula, when it is based on mean, AM means arithmetic mean. Mean base చేసుకొని formula వచ్చేసి it symbol, coefficient of correlation symbol is gamma. Gamma is equal to sigma xy, capital X capital Y, by sigma x square into root of sigma y square. Here we have given two sets of variables, small x, small y. What is capital X? Here you observe capital X is equal to small x minus x bar. Small x means given data. We have given two sets of data, that is small x data, small y data. But what is capital X here? Small x minus x bar. X bar means the mean of given data x. Mean of, first we have given x observations and y observations, two sets. Correlation means relation between these two sets and another. Kabatti x, y observations are there, two sets of observations. Suppose xi's are given, you find x bar, mean of x set first, sigma xi by n, x bar. Similarly for y set, you find the mean of y set, which is sigma yi by n, which is y bar. So first finding the means of these two sets, x set mean is x bar, y set mean is y bar. Okay, after that capital X is small x minus x bar and capital Y is small y minus y bar. You remember we have given small x y only. Okay ma? Right. What is the formula for gamma? First formula, gamma is equal to sigma x y by root of sigma x square into root of sigma y square, where capital X is equal to x minus x bar. Here x bar is mean, y bar is also mean. Kabatti when mean we know mean, that this one is called as mean method also. First you find means, then write capital X capital Y, then put into formula. So in another way it can be written as sigma, in place of capital X put X minus X bar, that's it. Capital Y put Y minus Y bar, this one. Similarly, in place of capital X square means X minus X bar, square means bracket petti whole square. Capital Y means Y minus Y bar whole square. Same this formula in terms of small letters ante. Same ide. ఏదో ఒకటి గుర్తు పెట్టుకోండి. So remember the first formula, this one. Next, the formula for coefficient of correlation is another formula is this. So it is better to remember first formula. So you let this formula is also usually we use. Suppose sigma x sigma y. What are the sigma x sigma y? SD of x group, SD of x data. Sigma y is SD of standard deviation of y data. Here directly we take small x small y. Okay ma? Where sigma x is SD of x series, sigma y is SD of y series. Remember this formula also. When sigma x sigma y, no, you use this formula. Okay ma? So when deviations are taken, already we see first formula. What is the first formula? This one. This is called as mean method. This is called as mean method, this one. Next, second one, if SDs are given, SD method. Don't use this method, no. First method, mean method. Then sigmas are known. Second method. Next, deviations are known. That means deviations means assumed mean. Deviations ante d values తీసుకుంటున్నామంటే assumed mean. Now gamma is equal to n into sigma dx dy minus sigma dx into sigma dy, root of n sigma dx square minus sigma dx whole square, n sigma dy square minus sigma dy square. Deviations are known. D values. Suppose we take the problem, then you can understand easily. Here you observe, this is dx into dy value. Find dx into d. First find dx, then find dy. Dx into dy. After that, let the summation. What about this? Dx, find out dx. Let the sum of dx into find dy, sum of dy. That's it. This is product of dx dy. Then let the sum. Okay. Here observe n sigma dx square, dx values ki square, but here dx square values ki sigma idi summation, but here dx summation whole square. You remember this formula ma, very important. So use the first formula. Second one is sigma x sigma y, and this is the third formula. When deviations are taken from assumed mean, this is the third formula, where dx is x minus ax. You know this. Dy is a minus x, y minus ay. The formula for coefficient of correlation, this is the fourth formula. We use this formula only when the covariance of two variables xy are known, and this one is standard deviation of x, this one is standard deviation of y. In numerator we have covariance of x and y. When we know the covariance of x and y, then only use this formula. Here also, how can we find covariance? This one, 1 by n sigma xy minus sigma x by n sigma y by n. This is covariance. After finding covariance, you substitute here, then we get gamma value here. So better it is used formula 1 and formula 3. When covariance of xy is given, then directly you substitute and use this formula only when covariance of x and y given. Don't find this one. Okay. See the first question. Find Carl Pearson coefficient of correlation from the following data. Coefficient of correlation. Coefficient of correlation means minimum we need 2 sets of observations. Here we have given 2 sets of observations. First one you take it as x small xi, second one small yi. Xi or x small y. I am going to use the first formula here, that is mean method. That means first you find means, arithmetic means. The first one is x, you take it as small x, second one small y. Okay, next x bar is sigma x by n. Xi anukunna no problem. Sigma x, add is all values by number of observations are n. Kabatti small x bar, mean of the first one small x, second one small y. Minimum we use 2 sets. First one is x set, second one is y set. To find coefficient of correlation, we use minimum 2 sets. Okay, x bar is sum of these values by 10. You get mean of x bar. Similarly, y, this is small y data. So y bar is sum of these values by 10. You get y bar. Now we get mean of x bar, mean of y bar. Then you find, you frame the table. So wages x, small x. In this small x values first column ga rasan nenu. Idi small y tarvata chuddam. Small x note chestunnam first column. Next capital X is small x minus x bar. X bar means mean of x. 99 వచ్చింది. కాబట్టి ఈ కాలంలో మీరు capital X అంటే small x minus 99 పెట్టాలి. X bar is 99. Small x minus 99. So what is the first one? 100 minus 99. Capital X అమ్మా ఇది. ఈ కాలం అంతా capital X. కాబట్టి capital X is small x minus x bar means small x minus 99. So small x is 100 minus 99 is 1. 101 minus 99 is 2. 102 minus 99 is 3. Like that you fill the x column like this, x column, and write sigma x. Next, after finding capital X, find x square. 1 square 1, 2 square 4, 3 square, like that you get 9. Write sigma x square. Add all this, you get sigma x square. So this is for these columns belongs to x item. Similarly, you frame y item, same, given y values, cost of living y values. Next, capital Y is small y minus y bar. Here y bar is 95, mean of this one ma. X bar is 99, y bar is 95. Okay, now this is small y given data. Capital Y is y minus y bar, that means small y minus 95. First capital Y column is first one, small y 98 minus, is 98 minus 95. So plus 3, 99 minus 95, 99 minus 4, 97 minus 95, 2 వచ్చింది. Okay, 95 minus 95, 0. So this is capital Y. After y, finding y square అంటే squares of these values. Okay ma, right. Y కి సంబంధించి related to y we have 3 columns are there. Next, find x into y. What is x into y? Capital X values this, capital Y values this. Then x into y, first one plus 1 into plus 3, plus 3 రాసాను. Next x, second x, x2 అనుకోండి, 2 into 4, 8. Next 3 into 4, 12. Next 3 into 4th one, plus 2. Okay, 3 into 2 వచ్చేసి 6. So write all x into y values and add all these values, you get sigma xy. Now we have sigma xy is 61, sigma x square is 54, sigma y square is 96. Now what is the formula? Gamma is equal to sigma xy by root of sigma x square into sigma y square. What is sigma xy from table? 61. Sigma x square is 54, sigma y square is 96. After calculation you get 0.847. So for the given problem we have the correlation coefficient is 0.847. 0.847. We have given 2 sets of observations. What are given here? two sets of observations. First one is X column, second one is Y column. Wages, take it as X column, small x. Cost of living, take it as Y column, small x, small y. We are going to use mean method. So we find first X bar, X mean 99, sigma x by n. Similarly, Y bar, yi, sigma yi by n, X bar, Y bar. Then frame the table. For capital small x, small y given values. For small x, find capital X, x minus x bar. After finding x, find x square. Similarly for y also, last column x into y. This x values, capital X values, capital Y values. We need sigma xy value, summation. Similarly sigma x square, sigma y square. Then substitute in this formula, you get this value. For all problems, use the same one. Here we have directly given, what is the question? Calculate of the correlation coefficient for the following heights of fathers X and sons Y. So heights ఇచ్చారట సెంటీమీటర్స్ లో. ఫాదర్ ని X గ్రూప్ అనుకోండి, సన్స్ గ్రూప్ Y అనుకోండి. These values we have given there. These values we have given there. X values. Next Y we have given. Then directly we have given x square. Then y square into xy. Find x bar first. X bar is sigma x by n, 68. Y bar is 69. Here use the gamma formula, covariance xy. Covariance xy is nothing but 1 by n sigma xy minus x bar y bar, x bar into y bar. This is the covariance of xy. Okay. Then sigma x formula is this, sigma y formula is this. Then substitute the values, you get this one. Maximum you don't use this covariant formula, use the first one. First problem use chesinde use cheyandam. Then calculate the correlation coefficient for the following, same method. Xy, given xy, then you write xy. First find mean, use the first formula only, don't use this formula, use the first formula. So you write, what is the first formula? What is the first formula? The formula is first find x bar, then y bar. What is x bar? Sigma xi by n. Similarly find y bar, sigma yi by n. Then frame the table, capital X, capital Y, and capital X square, capital Y square, capital X into Y. Formula is gamma is equal to sigma xy by root of sigma x square into root of sigma y square. You use the first formula. Here also use the first formula, don't use this formula. Okay. Like this, x value, see here, x value, y value, capital is x minus x bar, capital Y is y minus y bar, then x square, y square, xy. You get sigma xy is 60, sigma x square is 290, sigma y square is 22. So substitute these values, and x bar is 59 ma. X bar is 59 here. X bar is 59. That's why capital X is x minus x bar means x minus 59. What is capital X? First capital X, 50 minus 59 minus 9. Third one, 55 minus 59 minus 4, like that. Here also y minus y bar. Find y bar, you get all capital Y's. Y bar is 14. So in the table, y minus y bar means y is 11, y bar is 14. Idi y minus 14, fixed, y minus 14 here. So 11 minus 14 minus 3, 13 minus 14 minus 1, like that. So after finding capital X, capital Y, find x square, y square, x into y. Let the sum of these values, sum of sigma x square, sigma y square, sigma xy. Okay. So use the formula, you get the coefficient correlation is 0.7512. 0.7512. Okay ma. See the next problem. Given n is 10, already we have given this data. Sigma x is 5.4, sigma y is 6.2, and sum of the product of deviations from mean of x and y is 66. Find the correlation coefficient. Okay ma, here we have given n is 10, sigma x sigma y, and what is the next one? Sum of product of deviations from mean of x and y. Oh, x into y, product means x into y. ఈ x into y ని సమ్ చేశారు. సమ్ ఆఫ్ అంటే సిగ్మా xy is 66, that is meaning here. Sigma xy is 66 here. So we have given sigma x sigma y here. Then sigma x is 1 by n sigma square and so on. Okay ma, sigma x sigma y, this is sigma xy is 66. Use the formula gamma is equal to note down ma, gamma is equal to sigma xy by sigma xy, n into sigma xy by sigma x into sigma y. Now that is equal to 10 into 66 by 5.4 into 6.2. Finally you get the value is 0.1971. Okay ma, finally you get, this means sigma x into y. What is sigma x into y? This is the formula. In place of this put capital X. Directly formula gamma is equal to sigma xy by sigma x into sigma y. So this is capital X, this is capital Y. So sigma capital X into capital Y is 66. This one is sigma x is 5.4, sigma y is 6.2. So you get 0.1971. So in this class we observed the formulas for correlation coefficient, mainly mean method. Formula is gamma is sigma xy by root of sigma x square into root of sigma capital Y sammanni, where capital X is small x minus x bar, capital Y is small y minus y bar. This is the first method. Then deviation method, dx dy. Then last one in Japan, gamma is equal to sigma xy by gamma is equal to sigma capital X into y by gamma x into gamma y. Okay ma, here we see the coefficient of correlation. Okay.